Welcome everyone. This is the video for topic 11, lesson 3. And in this set of notes, we're going to be combining quite a bit of stuff from earlier topics into one sort of set of notes here. So I'm not going to get too into it because most of the stuff we already know how to do. I put a list of the 5 steps that you need to follow in order to be successful for this type of problem. The only new thing here is some vocabulary. Over here at number 4, you're going to be expected to tell me if the line is linear or nonlinear. And linear just means that it forms a line, and non-linear would mean that it is a non-line or it is not a line. So all you're going to need to do is graph these points from the table and make our line using the straight edge or ruler. We're going to need to find the slope of that line, which we talked about earlier. You're going to tell me if it's linear or nonlinear, and then tell me if the line is proportional or non-proportional. And that is something that we had discussed earlier in the topic 11. So let's jump into example problem number 1 here. And the first thing we need to do is to graph each of these 4 points that are in the table. So first point is located at 0, 1. If I start at the origin, I am not going to move left or right. I'm just going to go up 1 and plot my point. The second point is located at 1, 2. So I would start at the origin, go to the right 1, and then go up 2 and plot my point. The third point is located at 2, 3. Again, start at the origin, go to the right 2, and then up 3. And then the last point is located at 3, 4. I would start at the origin, move to the right 3, and then up to 4, and plot that last point. You can go ahead and take a ruler or a straight edge to connect the points and make your line. I'm going to use my line tool here. Once you've gotten your line, the next thing we need to do is find the slope of this line. And hopefully you remember from earlier in topic 11, the slope was the change, the amount of change that you did vertically over the amount of change that you did horizontally to get from one point to the next point. So I'm going to go back and make my slope triangle. And if you recall, I like to start at this point that is furthest to the left and then just work my way to the next point. So be kind of tiny here, but here is your vertical change, the yellow line. And you can see that that is just moving from 1 to 2, so that is a jump of 1. And then our horizontal change will go into purple again. Our horizontal change is not very big either. Is going from 0 to 1 over here, and then is a jump of 1. So slope, again, the vertical change over the horizontal change, the yellow distance over the purple distance if you're into the colors there. So that would be a 1 over 1 slope, which we can just say is 1. And again, that means to go from each point to the next point on the line, you would go up 1, right 1, and you would land right back on that line. Is this blue line linear or nonlinear? And very obviously that does make a straight line, so it is going to be linear. And then the last thing is this line representing a proportional relationship. Remember, for it to be proportional, the line had to be straight, which we can see that it is, but it also had to pass through the origin of the graph, and it does not pass through the origin of this graph. So this line represents a non-proportional relationship. Let's go ahead and look at example problem number 2. Going to do the same thing, going to graph our points, draw our line, find the slope, tell me if it is linear, nonlinear, and proportional or non-proportional. So let's graph these points. The first one is at 2, 4. So I would start at the origin, go right 2 and up 4. Second point is at 3, 6. That means I would start at the origin, go right to 3 and up to 6. The third point is at 4, 8. Again, start at the origin. The first number tells me to go right to 4 and then up to 8 and then plot my point. And then I have the last point is at 5, 10. So right 5 up to 10. And then I can go ahead and use my straight edge to connect my points, form my line. I'm going to go ahead and use my slope triangle to find the distance from point to point. Again, I'm going to start with my vertical change, which is my yellow line. Drawing that, I can see that there are 2 jumps there. So that is 2. I'm going to draw my horizontal change in purple. Again, little snug there, but you can see that that is 1 jump. Remember, slope is vertical change over horizontal change, so that would be the yellow line, which is 2 over the purple line, which is 1, and 2 over 1 is the same as 2. And we can tell that that is definitely a linear line. It is a straight line. So we'll put an L for linear. And then the last question, whether it's proportional or non-proportional. Remember, to be proportional, it has to be a straight line, which we know that it is, and it has to pass through the origin. And I can see that that line passes through the origin right there with my green dot. So this line is a proportional line. I'd like you to go ahead and pause the video and try the practice problems down below. You're going to do the same thing. You're going to graph the points, draw the line, find the slope, tell me if it's linear or nonlinear, and then tell me if it is proportional or non-proportional. You can check back in a few seconds to see the results. Okay, here are the results for the practice problems that we wanted you to try. Double check and make sure you did a couple things the same as I have. Make sure that you plotted the points in the same location. Make sure your line looks like mine. Make sure your slope triangle matches my slope. Should have a slope of 1. And then for practice problem 2, you should have a slope of 1/2 or 1 over 2, up 1 over 2. And then practice 3, you should have a slope of up 2 over 1. If you are not getting those results, please make sure you say something so that we can get you on the right track. And if you have any other questions, please make sure you ask.